So hello everyone, welcome to our group, Ask Geology group, a whole new way to understand our Mother Earth. So in the last video we just saw this question number, this is numerical number 37, which was actually a geochemistry question, not basically geochemistry but thermodynamics question. Okay, thermodynamic numerical we solved, and in this video we will see the explanation or the derivation of the formula. Okay, derivation of the formula, so that it will just make a clear visualization, or that will just make your visualization more clear. Okay, so let's just see. This is actually the question number 54 that we solved as it in GATE 2018. This is actually, you can see this is 14.9. actually this is the answer is around 43 point, this is 9277, this type. Okay, so answer is okay, and I think this formula you all might have just remembered, but let's just derive. Okay, now in any ideal state or system, all components are in internal equilibrium. So I'll just write down. Okay, in any ideal state or system. Okay, because in thermodynamics we use this terminology system. Okay, so system, component, surroundings, these are the three parts where we just define a particular system, its surroundings and the components. Okay, in a system, in ideal system, all components are in internal equilibrium. Okay, internal equilibrium. Okay, so when we mix two or more separate system components, okay, like this in the last class, this was gas A and this was gas B having volume B1 and volume B2 with 5 moles, and this is 3 mole. And if we are just mixing, and another thing, it just told that whatever the work done was here, that was only mechanical, and it was an isothermal condition. In isothermal condition, first thing. Second thing, only mechanical work done. Okay, only mechanical work done. That's why these, so that what we can just infer that these two gases, they are not chemically reacting. Okay, non-chemical, or these are not chemically reactive, non-reactive gases. Okay, if they react chemically, then some of the work done in that chemical reaction, they will have to do some kind of work, no? So that will be your chemical work, but it is mentioning that all the work done, that is mechanical. How mechanical? Because these two are like miscible solids, but they are not reactive when they will mix. Okay, when they will mix, and during mixing process, okay, let me just use some different colors. Okay, for A I am using green. Okay, now these are the molecules of A, okay, in the mixture. And for the volume B, these are the mixture, okay, sorry, these are the molecules of B, these are black. Okay, these are black in the mixture. Now when they are mixing, okay, when they are mixing in the starting part, this is volume B1, this is volume B2. Okay, when we mix these two more separate system components having different compositions, okay, without chemical reaction, ideal, okay, without chemical reaction, by thermodynamic operation, there is a small partition established between these different system. Okay, कुछ time के लिए there will be some partition, that means they will not directly mix for some time, maybe for 1 second or 2 seconds. There will be creation of a barrier. Okay, okay, and after some time this barrier will be vanished. Okay, this barrier will be destroyed. Okay, this barrier will be destroyed. Okay, when we'll mix two systems, there exists a impermeable partition. Let me just write down. Okay, when we mix two systems like in this case A and B, okay, there exists an impermeable partition, okay, for small time. Okay, what is that? That is both have different internal equilibrium. That is, both have different or identical internal equilibrium. Okay, maybe this gas, okay, in this gas it has some other like whatever they are in internal equilibrium, they are in this B, it is maintained in a different equilibrium, internal equilibrium condition. For example, if I am just containing here hydrogen, and in this case oxygen, hydrogen is very light. Okay, so its internal equilibrium condition will be different as compared to the internal equilibrium condition maintained in B where oxygen is present. Okay, but when we are mixing, then they will try to this blue, okay, this black, they will try to move this side, they will try to move this side. Okay, so there will be moment on a randomness that will be created inside the system. And this green color, they will also try to move inside. So in the initial time, whatever the barrier was present, that barrier will not be present after some time. Okay, and due to this moment, the entropy that is changing in this mixture, okay, the entropy that is the S is changing in the system, and this change del S of the mixture we calculated. Okay, del S of that mixture we calculated. Okay, so this after this barrier is present there na, okay, as it is happening without any thermodynamic operations, no heat is transferred or no work is done. Okay, so whatever the entropy of mixing is entirely accounted for by the diffusive expansion of each material into a final volume. Okay, these are the diffusive conditions, they are moving. Okay, so whatever the entropy of mixing, okay, I just write down entropy of mixing is entirely accounted for whatever that accounted for, it is by the diffusive expansion of each material, in this case these are the gases, each materials into a final volume, okay. Till here I think no doubt should be there. Okay, so that if we mix two ideal gas at same temperature and pressure, they are initially separated by a dividing partition. Okay, one barrier that comes into picture, but upon removal of this dividing partition or that barrier, after some time, because they are not chemically reactive, they will just diffuse into each other structure. So after removal, that the barrier will not be present there. So upon removal of this dividing partition, they will expand into a final common volume. Okay, that is the capital V. Capital V is equal to V1 plus of V2. During the formation of this capital V, there will be some diffusive processes. Okay, that's why the dividing line that will be not present. So in this case, we will just count that del S of the mixture, in this case 2, okay, which is given by minus of NR, okay, then Xi ln Xi. This is summation of I is equal to 1 to N. Okay, so this is your total number of moles. R is your universal gas constant. Okay, and xi, what is this xi? Xi is the mole fraction. This is the mole fraction of I component. Okay, now we'll just see that how this del S mix, it has the thermodynamic implications, how it is acting, we'll see. Okay, so in this case, that Vi, if we just consider Vi, this is the volume of the ith component. Okay, this is a volume occupied by ith component in the system. Okay, so can we just write down that Vi is equal to Xi capital V? Okay, how much it is just contributing to the total volume, that is the volume of the ith component, and Xi is the mole fraction of their ith component. Okay, so after partition is removed, okay, after partition is removed, so Ni will be your nxi, sorry, this is small n xi, this n is your mole fraction. Okay, don't confuse. Okay, so the total mole fraction of ith component, so total mole fraction, sorry, mole fraction of I component is equal to, this is the simple mole fraction into individual mole fraction of all components, individual mole fraction of all component in the system. Okay, this is clear. Then okay, so अभी क्या करेंगे, now all I component will combine to final volume. All components will combine to form the final volume. Okay, final volume. In this case we just took A and B. Okay, but if there are some other types of other elements or other gases are present, then that will all the whatever the all they will contribute finally to final volume capital V. Okay, so in this case we can write down nxi r ln Vy Vi, इसको लिख सकते हैं. Okay, for each component of gas, this is only ith, for each component of gas, so we can write the entropy mixing causes volume change. Okay, so in this case what is our conclusion, that entropy of mixing causes volume change, or this change in volume that causes some entropy change in entropy, because in this case we are adding A and B and final volume capital V. Okay, so if we are just adding these two systems, if there is a change in volume, because it is some V1 volume, it is V2 volume, the final volume is V, the volume is changing, so this change in volume that can causes the change in entropy. Or in this case we just define that how the change in entropy or the entropy of mixing that causes the volume change. Okay, so we can just rewrite that nxi r ln V by Vi is equal to nxi r ln xi. Okay, because we are just writing that this change in volume is also happening due to this smaller mole fraction combination. Okay, mixing of all those gases, that is also contributing to the change in volume also. Okay, so if we just expand this, what will be our final expression? That will be nr, then bracket start, xi ln v by vi plus of this 1, okay, x2 ln v by v2, that will be, okay, that will be nr into x1 ln x1 plus of x2 ln x2. In this case, for a we are considering x1, for b we are considering x2. Okay, so likewise we can see that del mix of g, in if we just considering in thermodynamics, g, okay, g is equal to del mix h minus of t del mix s. Okay, s is your entropy. Okay, so you can see how this change in entropy is being, we are just making some relation with the Gibbs phase rule or the thermodynamics. Okay, g is equal to h minus of t del s. So the total energy, total mixing energy, Gibbs free energy, that will be equal to, this is actually the thermodynamic equation, basic thermodynamic equation. So if we just mix those things, then these are the parameters how they will change. Okay, so this is all about that how this change in entropy is causing your change in volume, or change in volume is causing change in entropy when two separate phases are not mechanically reactive. Okay, sorry, not chemically reactive, but they can be mechanically, they will diffuse, and due to that diffusion they are doing some kind of work that is purely mechanical, and this purely mechanical energy or work done, that is contributing to the change in your entropy. Okay, so guys, thank you very much, and these are the numbers you can contact with. This is our email ID. There will be a link tree provided. Okay, link tree will be provided. You can just come to our group if you want to join. So thank you. Save our mother earth, go green, and have a good day.